the derivative of a function f of x, that's our function, with respect to the variable x, with respect to the variable x, is a function f prime those marks and the problem. It's a function f prime whose value of x is I think I need a mark here. Whose value of x is you said you remember that rule. What does that rule mean? The one that you did in secondary. It says what? What do you know about first principle? First principle is says what? Guys, so now the derivative of a function f of x with respect to the variable x is a function f prime. This means a derivative whose value of x is f prime at x, which is equals to the limits of x of h approaching 0, of h approaching 0 of f at x plus h minus f at x divided by what? By h. I hope all of you know this rule. Any question? Any questions so far?
No.
We have no question. Now, can I erase? Can I erase, guys?
Yes.
Yeah. So now, by writing, let's say z is equals to x plus h, so that our h must be equals to what? When you make h subject to the formula, you get what?
X minus z.
Pardon?
X minus z.
H minus z, right? Ah, you said what? When you make
X minus
formula, what do you get?
X minus z.
When you make h subject to the formula, do we get x minus z? Guys, when we take x to this other side, what do we get?
It's gonna be Z minus X.
We are going to get Z minus X. Are we fine now?
Yes.
Yes.
So now, it simple means when we substitute those things on our formula, now our formula changes. Are we fine? It means we are going to have what? Our formula now is going to say what?
It's gonna be f prime of x, the limit h.
Is equals to
The
the
limit h
limit
is
of what? Remember h is what?
Z minus x.
Are we fine?
Correct.
Then there be x f at what? At z. Are we still together? Minus f at x divided by, we're going to divide everything by what? By z minus h. Any question before we proceed? This kind of equation, you will meet it whether on a test. So can I proceed?
Yes.
So now let's take an example. Example. They say use the definition, use the definition to find f prime at x. You are given f at x is equals to x over x plus 1. You are given f at x is nothing but x over x plus 1. So what are we going to do? We're going to say f prime, we know that f prime at x is equals to the limits of z approaching x. I will find with that. Then we'll put fx, f at z minus f at x divided by z minus. Meaning that f at z, because we know f at x, it simply means that our f at z is equals to, when there is an x, we are going to plug what? Z. Is equals to z over z plus 1. Do you understand this? So now, I will erase and restart this question here on top so that we have enough space. So that we may have enough space. So now, right. So as far as we concern, remember we've got a function which says f at x is equals to x over x plus 1. And we got f at z, which is equals to z divided by our z plus 1. Now we wrote the formula f prime is x. We say this is nothing but the limit of z approaching x of f at z minus f at x divided by z minus x. So when we proceed, we are going to substitute where there's f at z, we're going to plug f at z. Where there's f at x, we're going to plug f at x. So this thing is going to be simple and straightforward. This is equals to, remember we're doing mathematics, we continue with our equal sign. This is the limit, you must not forget the limit of z approaching x. This is z over z plus 1 minus x over x plus 1 all divided by z minus x. So from our numerator, we're going to find the LCM. It means this is equals to the limit of z approaching x. LCM of our numerator, remember we multiply the denominators, which is z plus 1 is going to be multiplied by x plus 1. We say this one goes how many times here? Is going to crash with the one that is same width, and we're left with x plus 1. X plus 1, we're going to multiply with z, which means on our numerator, we have z multiplied by x plus 1. Then negative sign, we write it the way it is. We say x plus 1 goes how many times here? It's going to hide with x plus 1. Then we left with z plus 1. Then we say z plus 1 multiplied by x. It means we have x multiplied by z plus 1. But this equation was nothing but divided by z minus x. Are we still together? Are you following?
Yes.
Then on our numerator, we remove the bracket. This is the limit of z approaching x. X times z, we have got what? Zx or xz is up to us. So we've got zx. Z multiplied by 1, positive z. Then negative x multiplied by z, we've got negative zx. Negative x multiplied by 1 with negative x. All we are dividing here by z plus 1 and x plus 1. So now, but this thing is nothing but all are divided by z minus x. So are we good on that stage? Then on our numerator, we're going to group the like terms. It means zx and zx, they are going to cancel each other. Then it means now we're going to left with this equation of function x. This is the limit of z approaching x. On our numerator, we're left with z minus x. This is z minus x divided by, this is z plus 1 multiplied by x plus 1 multiplied by 1 over, remember this is like over 1. So when we introduce the multiplication, numerator becomes a denominator and the denominator becomes a numerator. So now, this is multiplied by 1 over, this is like z minus x Then we see in maths, we know that those two, they are going to cancel each other. We're left with the limits of z approaching h of 1 over z plus 1, x plus 1. Anyone with a question from where we are? No one with a question? Hello? Anyone with a question? Guys, you must respond very fast. So now, z is going to approach x. It means when this is z, we are allowed to substitute with x, but because z is going to approach x, the limit is going to vanish. Vanish, I mean it's going to disappear. So this is 1 divided by x plus 1, x plus 1. You can continue if you love mathematics. This is x plus 1 to the power 2. Even there you can continue and you end it on 1 over x squared plus 2x plus 1. It's up to you. So, any question? Guys, any question?
No.
So if you find a question says use the first principle or use the rule, this is the rule that you are going to use, the one for limit of z approaching x. Here at tertiary, we are not interested by the one for limit of h approaching 0. We are interested on this one for z. So in the meantime, you can write this somewhere so that you might try to do it by yourself. And where you go wrong, you ask. F at x is equals to x over x squared plus 1. We are using the same thing, the same rule to solve. Are we fine?
Yes.
Hello.
Oh,
Iyo ya f at z na yone ro ṱoḓa ro fhiwa kana ro tea to zwi ḓivha zwo ṅwaliswa zwezwo?
you mean the rule?
Yeah.
The question will be use the definition, alternative definition of the derivative to differentiate the following. They give you this kind of a question. So yourself, you must know this one. I'll find.
Yeah. Ndi khomba hezwo zwi re nga nṱha hezwo zwe ha thoma ṅwala pfhi f at x equals to x over x plus 1 ha pfhi f at z.
They will give you that function.
Ya nga fhasi ri vha ri wana kaya?
F at z is the one that is on the formula. You are going to substitute. You must get fz first. So fz simple means that you see here where there's a x. Now they put what?
Z.
It means on your equation of f at x, where there's an x, you're going to replace it by z.
Zwamburisa inoni example ina ripa f at z yashu ya toingwana na squared.
Yes, if it is squared, is squared.
Mm.
Our f at z here is going to be what?
Z over z squared plus 1.
Good. That's correct.
Okay.
So are you satisfied?
Yes.
Hello?
Ndozvipfa ndozvipfesesa.
Okay. Is there anyone with a question? Guys, is there anyone with a question? Okay. Differentiation rules. When we're talking about the differentiation rule, we're talking about the power, the sums, the differences, product, the quotient rule, and stuff like that. So, but you must know that dx of, let's say, c is equals to 0. Or 5. dx of c is equals to 0. How is spelled together? Guys, I will spell together. Where it is not just equals to 0. It's equals to 0 where c is constant. It is equals to 0 where c it is our constant. I will find this.
Yes.
So let's say if f at x is equals to nothing but, let's say, 6 pi, I will find. So our differentiation f prime at x, which is also dx of what? Of 6 pi. This is also equals to 0. Why is it equals to 0? Because we don't have a variable x here. 6 pi is like a constant. I will spell together. 6 pi is like a what? It's like a constant. So now, let's take another example. Let's say you have got a function y is equals to, let's say, 3x. When you apply dy over dx, this thing is going to be what? 3. Do you still remember?
Yes.
Okay, but if you are given a function, let's say y is equals to 4x, they say find dy over dt. This is equals to what?
Oh.
Yeah, someone says 4. And what were you going to say in Swahili? Rivu, what were you going to say? Nyumani,
40.
Moloko. Guys, I'm hoping your mic can speak.
for x.
The answer here is 0. Why? We don't have t on our function. We're derivating the equation of y, but respect to t, we're going to check t.
Oh.
Are we fine?
Yeah.
Yeah, now let's talk about the power rule. The power rule. Where does those things that we're speaking come from? Applying what we call power rule. Power rule. So in power rule, if we've got a function y is equals to x to the power n, the y over the x is going to be equals to this one. This power is going to multiply with the coefficient here. Then we have got n. And n is 1 times n. This is n. Then we copy what we have, but we subtract 1 on a exponent. Our 5. Hello?
Yes.
So let's take an example. Let's say we're
Yes.
3x to the power 4. When we find the y over the x, this is equal to what? 4 times 3, x to the power of 4 minus 1, which is nothing but 12x to the power.
X to the power 3.
Guys, we're still together.
Yes.
Yes.
So now, let's say we have this kind of a function, which is y is equals to 1 over the square root of. Can you derivate that? The function which is y is equals to 1 over the square root of x. So take that function without simplifying it. Are we still together?
Yes.
You can't do what? You can't derivate
Without
without
simplifying.
simplifying the equation. So when we simplify, do you know that the square root is equals to 1 or 1 over 2?
1 over 2.
Then this is y is equals to 1 over, this is x to the power 1 over 2. Do you know that?
Yes.
Then this is like y is equals to, we are not allowed to deal with the fraction when we derivate. Y is equals to, this is x to the power 1 over 2, to the power negative 1 over 2. So do you understand? Remember, from the law of exponents, we know that a to the exponent of negative n is like 1 over a to the what? To the n. If we've got a numerator, when it goes to the denominator, the exponent just gain negative. Here, this is like 1 multiplied by. And then we've got 1 here on our numerator. This is 1 multiplied by. This one, it comes to the numerator. Our 5. Guys, are we fine?
Yes.
So now, here we are. This is where we are allowed to derivate to find the y over the x. It means we've got 1 times minus 1 over 2. This is minus 2. x to the power minus 1 over 2, we subtract 1. This is nothing but what? This is negative 1 over 2 x to the power what? Is it negative 3 over 2? So we must avoid negative exponent. It means we'll be left with minus 1 over, this is 2 x to the power of 3 over 2. Then that is our final answer. Any question? Any question, guys? Any question? Guys, time you must respond.
No.
Hello? Hello.
Rosipha.
Sure.
A.
So now, can I erase? Can I erase?
Yes.
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 Okay. So now, and B. We must also know about the equation of a tangent.
Hey.
Please look your mic. Equation of a tangent. Equation of a tangent. So let's say you're given a function y is equal to x squared. They say find the equation of a tangent at point 1 and 1. They say find the equation of a tangent at point 1 and 1. I will start together. Hello? Hello, good people. Are we still together?
Yes.
Yes.
So the equation, the general equation of a tangent now they know that it says y is plus what? Plus c. Are we together?
Yes.
Then, and it says y minus y1 is equals to m when m is a gradient into x minus x1. Myself, I'm interested in this one, the last one. So, I can say to find the equation of a tangent, it will be like a notes then to find the equation of a tangent you derivate. Why do we derivate, guys? I mean, like, why do we derivate? When you derivate, you get what?
The equation.
The gradient. When you derivate, you get the gradient. We derivate to get the gradient at a point. How fine.
Yes.
So now, to find the equation of a tangent, you do what? You derivate. How fine. And substitute the value of x to get the gradient at that point. So let's go and derivate this guy. Solution. We're going to say dy over dx is nothing but what? 2x. How we find? Hello?
Yes.
Then at x, our x point is what? We're given the point. The point is always in the form of x and y. Our x point is what?
It's 1.
Is 1, right? Then at x equals to y, dy dx is equals to what?
Yes.
At x equals to 1, our derivative will be equals to 2. Because when there's the x, we substitute with 2. Are we fine? Then this 2 is our gradient.
Yeah.
Then after that, we use this formula. I told you, you can use this or that. Here you're going to substitute your gradient and you substitute x and y you are given to get the what? To get the point. How we find? Are we still together? Hello?
Yes.
Now, it means I'm going to say y minus y1. This is a straightforward formula, m into x minus x squared. So now I know that my m is 2 and the y1 and the x1 is those points. It's 1 and 1. It means I have y minus 1 is equals to 2 into x minus 1. So can you make y subject to the formula? Hello?
Yes.
Can you solve for y? If your mathematics is too good, you get y is equals to 2x minus y. This is the equation of the tangent.
Minus 1.
So I will find.
Yeah.
Can I erase? Guys, can I raise?
Yes.
Yes.
They said the curve one over 1 plus x squared. You will do this now for yourself. It's called a witch. Let's say it's called a witch of Maria. Agnes. By using an appropriate rule, of differentiation, find an equation. Find an equation of a tangent line to this curve, Find the equation of the tangent line to this curve at points -1 and half. At point -1 and half. This is 4 marks. So find the equation of a tangent line to this curve at a point -1 and half. So how we start together? Now, are you done to copy so that I may erase? Hello?
Yes.
So now, you will do this for yourself, né? And then did you see how do we find the equation of the tangent?
Yes.
Yeah, don't ignore, please do those questions and we will give you each other correction whether you got it or you didn't. So now, let's talk about sum and differences. Sum and differences. So let's say we've got the equation of y is equals to, we've got a function f at x plus or minus g at x. And we want nothing but dy over dx. This is nothing but it is equals to d dx of f at x plus or minus d dx of g at x. Are we fine with that? In other words, I mean, this is like we've got f prime and x plus or minus g prime and x. Because the derivative, if you don't want to write this, you can write this. I'll try. E.g., let's say we've got an equation which says y is equals to, let's say 5x to the exponent of 4 plus 3x squared minus 1 over x. Are we fine with that? Is it visible? So as far as we're concerned, I told you that you must avoid the fraction or before you derive it. So this one we're going to write it as y is equal to 5x to the power 4 plus 3x squared minus x to the exponent of minus 1. Is everyone there? Now, this is where we can apply dy over dx, which is nothing but, I told you that we multiply and we take 1 for the exponent. I will find. Do you want me to write 5 times 4, or do you want me to write the final answer for 5 times 4?
Final answer.
Okay, 5 times 4 is nothing but 20. X to the power of, we're going to say 4 minus 1, which is 3, plus 2 multiplied by 3 is positive 6x. On the exponent, we subtract 1, we get 1. So there's no need for us to write 1. Or if you think you are confused, I can say d dx, dy over dx is equals to d dx of 5x to the power 4 plus d dx of 3x squared minus d dx of x to the power minus 1. Are we sorted there? So now, this is nothing but, this is 20 x to the power 3 plus 6x minus x to the power of minus, it won't be minus, it's going to be plus x to the power of minus 2. Now, when we ignore the negative exponents, this is equals to 20 x to the power 3 plus 6x plus 1 over x squared. This is your final answer. Any questions so far? Guys, any question?
No.
Can I raise?
Yes.
I didn't left anyone behind, right? So
Yes.
now, is that a question? So let's talk about those things you will see them on the exam and test. Eh? Product rule. Let's talk about the product rule. I can say if our function y is given by f of x multiplied by g of x, and when we want the derivative dy over dx, this is nothing but is going to be equal to, we first copy the first function and we derivative the second, we write plus sign. Now we derivative the first and we copy the second. Any questions? Do you understand? Hello? Guys, do you understand?
Yes.
Let's take an example, e.g. if you are given a function y is equals to, let's say 3x to the exponent of 3 minus 1 multiplied by x squared plus e, I will find. We're going to do dy dx, dy over dx is nothing but, I told you that we copy the first one, but it's up to you. Which one do you want? Even here, you can derive this and you copy this, derive. It's up to you. I will find. Just because here is plus, it doesn't change anything. I will still together. You can derive the first, you copy the second, and you plus, but at that side, you don't derive the same function that you derivated at the first time. I will find. Hello? This is 3x to the cube multiplied by d dx of x squared plus e plus d dx of 3x cubed minus 1 multiplied by x cubed plus e. How fine. So now, this is nothing but we have our 3x cubed minus 1 multiplied by, what is the derivative of x squared plus e? What is the derivative of x squared plus e? What were you going to write? Now, what were you going to write here? You can't derive this one.
2x plus 0.
Yeah, it's 2x plus 0, which we won't write it. It's 2x because e is a constant. Where there's no x, 0. Plus, derivative of this is 9x to the power 2 multiplied by x squared plus. Now, we remove the brackets. It means it's nothing but, I can see that people are tired now. 6x, we are soon going to end. Soon we are going to end. We no longer have 10 minutes together. This is 6x to the power 4 minus 2x plus, this is 9x to the exponent of 4 plus 9x squared e. I will find. So we rewrite our equation in mathematics to group the like term 6 plus 9 is nothing but it's 15. 15 x to the power 4 plus 9e x power 2 minus 2x. So did you understand the product rule?
Yes.
We're going to the last rule, which is called the quotient rule. The quotient rule. So after this lesson, I'm 100% sure that you can answer many questions. Many. Can I raise? Guys, can I raise?
Yes.
So now, let's talk about the quotient rule. Don't throw away those notes or don't just copy to any paper that you will lose it because you have a problem, right? So now, let's talk about what we call the quotient rule. Quotient rule. The quotient rule. The quotient rule. So now, in quotient rule, let's say we have a function if y is equals to f at x divided by gx. Y is nothing but f at x divided by gx. So how do we apply quotient rule? So if we want dy over dx of this function, dy over dx is equals to d dx. When there's a y, we're going to substitute the function d dx of f at x divided by dx. D dx of f at x divided by gx. So now, this one is going to give us, we copy the function which is on the denominator, which is gx, multiplied by, we derivate the one on the numerator, means we're going to have d dx of f at x minus, we subtract. Now we copy the one on the numerator, we derive the one on the denominator. We've got f at x multiplied by d dx of gx. We divide everything by the numerator, raise it to the power 2. This is what we call the quotient rule. This is what we call the quotient rule. Or this is same as y prime is equals to g at x multiplied by f prime at x minus f at x multiplied by g prime at x divided by, this is g at x to the power 2. Any question? Any question, guys?
No.
You don't have a question, eh? Can I raise? Can I erase?
Yes.
So now, we're going to apply quotient rule. Let's take an example, then we end the class. E.g., let's say we've got a function which is y is equals to x over x plus 1. Let's say we've got that function. Or we can use x minus 1 because it's been a long time while we're using this x plus 1. X minus 1. It means our f at x is x and our g at x is this one. Right? I will try. We're going to write a formula dy over dx is equals to f at x multiplied by g prime at x, which is a derivative minus f at x minus f prime multiplied by g at x. It's up to you. I will find that. Hello? We are going to copy the numerator. We derivate the. We are going to copy the denominator. We derivate the numerator. We subtract. We now derivate the what? The denominator we multiply by the what? By the numerator we all divided by the denominator to the power 2. Are we still together? It's the same thing. Are we still together? Hello?
Yes.
Now, what is our numerator? Is x minus 1. I will try. What is the derivative of our numerator? Our numerator is x. The derivative of x is what? Huh?
1.
Is 1. Then we say minus the derivative of the numerator of the denominator is also 1. Multiplied by x, we divide by, we say x minus 1 to the power 2. Are we still together there, guys? Hello, good people. I mean, like maths is.
Yes.
Then we remove the brackets. We have x minus 1 minus x divided by x minus 1. When we group the like terms, we find x and x cancelling each other with minus 1, all divided by x minus 1 to the power 2. So I can tell that this is nothing but our final answer, which is it's going to end like that. Any question before we end the meeting? Any question before we end the meeting? Anyone with a question? Is there anyone with a question?